Hello everyone, and good morning. How is everyone doing today? Great. Alright, let's dive right into our corner. Let's check out a trending article from the archive. Today, we're looking at a super interesting topic from the world of human and computer interaction. Our new rules are rules. It's all about how we can make computers easier and more fun to use. The paper we're talking about today is titled Animated Transition Between Node-Linked and Parallel Coordinates Visualizations. The cruel is Charts, the Cordosi 4507.16,565. Wow, that's a long one. This research comes from some very smart people at the University of Rostock in Germany. So, let's get our thinking caps on and figure out what this is all about, okay, everyone? Imagine you have a lot of complicated information, like data about all your friends in a social network. You might want to see it in different ways. First, you might use what's called a node-link diagram. Think of it like a big spider web. Each person is a dot, or a node, and the lines connecting them show who's friends with whom. This is great for seeing the structure and all the connections. But if you also want to see other details about your friends, like their age, how many books they've read this year, or how many pets they have. For that, you might use a different kind of chart, called a parallel coordinates plot. This one looks like a bunch of vertical lines, where each line is a category, like where each line or age of pets. Each friend is shown as a zigzag line that connects their specific values on each vertical axis. Now, here's the problem the paper is trying to solve. When you switch from the spider web view to the zigzag line view, your brain has to work really hard. It's like poof, a totally new picture appears. You have to figure out all over again which dot corresponds to which zigzag line. This jump is called a context switch, and it can be super confusing. So what's the big idea from our researchers? It's animations. That's right, just like in cartoons. Instead of just flipping between the two charts, they make the dots from the first chart smoothly and gracefully transform. They morph into the lines of the second chart. It's like watching a caterpillar turn into a butterfly. The researchers wanted their animations to be two things. First, they must have good traceability. This means you should be able to easily follow one little dot with your eyes as it moves and stretches into its new line shape. You should lose track of it. Second, they need swiftness. The animation has to be quick. You don't want to sit there for a whole minute watching it. So they tested two versions. A basic one that was super fast but a bit messy, and an advanced one that was slower but much clearer. The advanced one used cool tricks like staging, where the animation happens in steps, and staggering, where the dots start moving one after another instead of all at once. Do you know what they found? The slow advanced animation was much better for helping people keep track of the data. Now you might be thinking, that's cool, pay no money. But how does this help me in my daily life? That's a fantastic question. Let's think of some examples. First, let's talk about user-friendly website design. Imagine you're using an app to manage your money. You might start with an ugly view showing how your different investments, like stocks and retirement funds, are connected. Then, with a click, the view could animate smoothly into a parallel coordinates plot. This new view would show things like growth and fees for each investment because of the smooth animation. You would instantly understand how the structure of your portfolio relates to its performance, making a complex topic much easier to grasp. Second, let's think bigger, like with VR, which are virtual reality and augmented reality. The scientist could be in a virtual lab, looking at a giant 3D model of a disease spreading through a community. That's the node-link view. Then, with a wave of their hand, the whole thing could transform into a huge parallel coordinates plot around them, showing data like age, vaccination status, and location for each person. The animation would guide their eyes, helping them see patterns they might have missed otherwise. It turns data analysis into an immersive adventure. And for our third example, let's consider accessibility in education. Imagine a student learning about history. They could see a node-link diagram of historical figures and their relationships. Then animation could morph this into a chart showing each person's lifespan, major accomplishments, and the regions they influenced. This visual connection makes learning so much more intuitive. For people who find it hard to process lots of information at once, these guided transitions can be a huge help. making complex knowledge accessible to everyone. So, how is this different from what we have now? Well, right now, we often use something called brushing and linking. This is where you have two charts side by side. When you highlight something in one chart, a same item lights up in the other. It's useful. But you still have to look back and forth. Your brain does all the work of connecting them. This new research with animated transitions does the work for you. It doesn't just link the two views. It merges them into one continuous, understandable story. It's a much gentler way for our brains to understand data. So this paper is all about creating beautiful, smooth bridges between different ways of seeing information. It helps reduce the mental effort needed to understand complex data, making it more intuitive for everyone. Isn't that just wonderful? That's all the time we have for today's article. I hope you all learned something new and exciting. Keep being curious, everyone, and I'll see you next time. Bye-bye.